Okay, guys, so let's talk about how to kind of apply this idea of a critical number and how to find extrema on this interval. So in example 2, they give us this function and they're saying find your extrema in this interval within this -1 up to 2. So the first thing I have to do is find my derivative. And what I'm going to look for, once I find my derivative, I'm looking for where are there critical numbers. So remember back in that first video, I talked about how critical numbers happen when there is a cusp or when the derivative does not exist. And then it also happens where the derivative is 0. So where is it undefined and where is it 0? Those are the two things that I'm looking for. All right, so in this first example, I'm looking at this function. I'm going to find my derivative first. So f prime of x equals, this would be 12x to the third minus, this would be 12x squared. So I'm checking to see when does that derivative equal 0 and when is it undefined. Well, with this one, there's no fraction. It's not a rational expression, so I'm not really too concerned about the undefined part. That's not going to happen in this case, but 0 would happen. So I'm going to set this equal to 0. I'm going to factor out a 12 and an x squared to make things easier on myself. So that's going to give me an x there minus a 1 equals 0. So when you can factor, do. It'll save you a lot of time. So then I've got to think about when would this be 0 and when would this be 0. So in this side over here, x squared equals 0, which means x is 0. So I need to think about 0. This one, x minus 1 equals 0. That means x could be 1. So if x were 1 or if x were 0, that's where something weird is happening on my graph. That's where I'm going to have an increase and then a decrease, or a decrease and then an increase. So I need to think about that. I'm going to make a table because I feel like it's easier for me to kind of visualize it in that way. So if I have this table, what I'm thinking about is on a number line, I need to think about my endpoints, so my -1 and my 2, and I need to think about anything inside that interval that's a critical number. So I'm going to think about my left endpoint. I'm going to think about my critical numbers. So I have 2 of those right now. And then I'm going to think about my right endpoint. So those are the 4 things that I have to think about in this problem. Now you could have several critical numbers, so maybe I have 3 or 4 different things in the middle there, but I'm always going to have my left and right endpoints to think about. So that means I need to think about what's happening to my function at -1 for my left endpoint. For my right endpoint, what's happening to my function at 2. For my critical numbers, I've got, I don't know why I put a parenthesis there, my function at 0 and my function at 1. And both of those are in this interval, and I just put them in order. Okay, so I'm actually going to figure out what is f of -1. So if I plug -1 into here, I get -1 to the 4th power. Remember, you're plugging this into the function, not the derivative. So if I plug in -1, that's -1 to the 4th power, which is 1. So 3 times 1 is 3. Minus, this would be -1 to the 3rd power, which is -1, times the 4, that's -4. So this is really plus 4, which gives me 7. So I just plugged this in. If I plug in 0, this one is a really easy one, I just get 0. If I plug in 1, I get 3 minus 4, so I get -1 in that case. And if I plug in 2, I get 2 to the 4th power. 2 to the 4th power is 16, sorry, and 16 times 3 is 48, minus, so 48, minus, if I plug 2 in here, I get 2 to the 3rd power, which is 8, times 4 is 32, so 8 or sorry, 48 minus 32 is 16. I'm trying to do all that in my head real quick. Okay, so that means I have the points -1, 7, 0, 0, 1, -1, and 2, 16. So what I'm looking for in this case is which ones are my maximum values and which ones are my minimums. Well, this -1 is the lowest value that I have up there, the lowest y value. So that means I have a minimum at the point 1, -1. Or I could have said f of 1 equals -1, but I just write it as a point. Then I have a maximum at, this is my highest value right here. So at 216, I have a maximum value. So those are my extrema in this problem. Okay. In example 3, this one is a little more complicated, so I wanted to make sure I covered something that wasn't just super easy to solve out when you set it equal to 0. So I'm gonna do my derivative of this. So the derivative of 2x is 2. And then minus, I'm gonna bring down my 2/3, and I'm gonna multiply it by this coefficient. So 2/3 times 3 is 2. And then that leaves me with x to the -1 from this. So 2/3 minus 1 is -1/3. And that's where this one gets messy. Because what that means is I have 2 minus 2 over x to the 1/3. And just to kind of give you a heads up, it's usually easier to kind of visualize what's going to happen in a function if you have one solid fraction and not two separate terms there. So I'm going to get a common denominator. That means I'm going to take top and bottom of this, so 2 over 1. I'm going to multiply both of those by x to the 1/3. So that gives me 2x to the 1/3 over x to the 1/3, right? Now, I'm not going to write that because I'm just going to write it as one big fraction. So minus 2, because these are going to have the same denominator, x to the 1/3. All right, so I feel a little bit better about that. I think I'll stop there. So now I have to think about those two situations again. What happens when it's undefined, and what happens when it is 0, right? So when it's undefined in this case is when x to the 1/3 is 0. If that's 0, we've got a problem. So remember, this is the same thing as the cube root. So that means that's going to happen when x is 0. So there's one thing I need to think about when x is 0. I also need to think about when this derivative is 0. So what's funny about this situation, and I'll write it out, but from now on I probably won't. So I have this whole fraction. When this equals 0, it's actually only when the top equals 0. Because if I multiply by the bottom, x to the 1/3 times 0 on both sides, that's going to cancel out, and I still get 0. So 2x to the 1/3 minus 2 equals 0. So that means 2x to the 1/3 equals 2 if I add 2 to both sides. And then if I divide by 2, x to the 1/3 equals 1. So remember, this is a cube root, right? So you might want to write it like that. And then just cube both sides. So that means x equals 1. So that's another one that I need to think about. All right, so now if I'm going to think this through, I need to think about my left endpoint. I need to think about my critical numbers, which I had 2 of them, and I would check, remember to check and make sure they are actually in your interval. So if they're not, I don't have to think about it, but this interval goes from -1 all the way up to 3, and 0 and 1 are in that interval. So that means I'm going to check f of 0 and f of 1 also. All right, so again, I'm plugging them into my function, not my derivative. I'm plugging them back up here because I want to know what's happening on the graph. So if I plug in a -1 to this function, I get let's do this one step at a time here. I get -2 for that first part. And then if I plug it in here, if I plug -1 in here, okay, so let's write this out. I'm going to take 3 times, this is going to be -1, but it is squared and cube rooted. So to the 2/3 power, this right here is the same thing as the cube root of x squared. So don't forget that little rule. Okay, so now I'm going to take -1 and square it. That gives me 1. And then I'm going to cube root that. I still get 1. So this is really just going to be 3 times 1, which is 3. So I'm going to minus 3 from that. Okay, so that means I'm going to end up with -5 for that one. All right, and then, sorry, let me get this over here. Okay, then I'm going to plug in 0. Well, that's an easy one. If I plug in 0, I just get 0. So this is 0. Let me write out those points. So -1, -5 was that one. 0, 0 was that one. This one, if I plug in 1, it's going to be pretty much the same as this one. If I plug 1 in, that gives me a 2 minus 1 to the 2/3 power is still 1 times 3 is 3. So that gives me -1 in this case. So 1 comma -1 is a point. If I plug in 3, I get 2 times 3, which is 6, minus I've got 3 times 3 to the 2/3, which means 3 squared cube rooted. So that means I have 3 times the cube root of 9. So I'm going to get that as a decimal just so that I have a better idea of what that is. So on my calculator, I'm going to take, I can really just take 3 to the 2/3 if I want instead of writing it as a cube root. So 3 to the 2/3 power is going to give me that, and then I'm multiplying that by 3. So I'm getting about 6.24. I don't know why I put 5 after I just said 4. So 4. And then if I take 6 and subtract 6.24, I get a -0.24. So that's an approximate answer on that one. But it is definitely, when I'm looking for my maximums and minimums, this one is definitely not the lowest point. This one is. And it's definitely not the highest point because 0 is bigger than that. So I'm not too concerned about having that exact value. I just want to know if it's the biggest or the smallest. So this one is my smallest. So I have a minimum at -1, -5. And I have a maximum at 0, 0. Okay. The last example I want to talk about is a trig function example, and this one always throws people for a loop. So we're going to talk about the unit circle a little bit. Okay, so first let's do the derivative and move forward from there. So the derivative of sine is cosine, so this is just 2 cosine x. Then the derivative of cosine is negative sine. So that makes this a plus sine of 2x. But don't forget chain rule. So this isn't just an x, it's a 2x. So I have to take all of that times 2. All right, so that means my derivative is 2 cosine of x plus 2 sine of 2x. Okay, so now I need to think through, how do I set this, like when am I going to know when this is equal to 0? So one thing that they did was they used factoring to help themselves out here. But the way they did that was they said, let's see, how did they, Okay, so they wrote this as cosine sine. Oh, this is really messy. I'm wondering if there's a better way to do it. So let's see if I can figure it out without doing it the way the book did it, because they made things really messy. Another option, just to throw this out there, you could graph this. So if you wanted to go to Desmos, let me write that down. If you want to go to desmos.com, I'm okay with you graphing this and then checking it just graphically. Where's that maximum point and that minimum point? When is it kind of flattening out, in other words? So when are those weird points happening? So in this case, let's see. I'm going to do, let's see. I guess I'll write it like they did because I don't think there's a better way to solve it. I was just trying to help you out a little bit. All right, so the sine of 2x, they used their trig rules and said that is the same thing as 2 cosine of x sine of x. So this is kind of going back to your trig rules. It may take you a while to kind of go back and remember those. We don't run across a lot of those where you have to separate things up like that. So don't get too stressed out about that. But this is one of those trig rules that you should have memorized. My guess is a lot of you don't. So that's just something we can talk about as we go on. But like I said, the most that we end up using are things like tangent is sine over cosine and things like that. So, okay, so I'm going to use this rule for now. So then I can factor this. So I can factor a 2 out of both of those, and I can factor a cosine out of both of those. And that's going to help me out quite a bit because that leaves me with just a 1 plus this 2 I factored out, so I still have a 2 left, 2 and a sine. So now I can say, when are these things 0? So when is 2 cosine of x 0? Which in other words, when is cosine of x 0? Right? So we'll look at that in a second. The other situation is when is 1 plus 2 sine of x 0? Well, that happens if I minus 1 equals -1, and if I divide by 2, this is when sine of x is -1/2. So if you go back over to your unit circle, so I'm just going to show you the unit circle real quick. I am looking for when is, let's see, it was cosine of x. When is cosine of x 0? So if I go over here, remember that your cosine is your x value on here. They want to know when is that 0. So when is x 0? That happens right here, and that happens right here. So pi over 2 and 3 pi over 2. That's the two cases where that happens. So this one is when x equals pi over 2 or 3 pi over 2. Okay, the other situation is when is the sine of x -1/2. So let's go back over here. Sine is your y value. So when is sine -1/2? So if I'm looking here, I've got one. That happens at, I'm sorry, my y value, guys, I'm sorry, right here, -1/2. So 7 pi over 6 is where that's happening. And then another y value where that happens is right here. 11 pi over 6. So 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 and 11 pi over 6. Now, if you have your unit circle memorized, you don't have to worry about going over there to figure that out. My guess is a lot of you don't have it memorized anymore, so that's okay. We'll get there. All right, so I'm going to use my left endpoint, my critical numbers. Let's see how many we've got. I've got 1, 2, 3, 4 of them. So critical number, critical number, critical number, critical number. And then my right endpoint. Okay. So first is when f of x is actually f of 0. My last one is going to be f at 2 pi. Everything in between is all of this other stuff. And if you're not sure of the order, it's okay. But I'm going to put them in order just for my own OCD. All right, so pi over 2 is first. 7 pi over 6 is actually next. Then my 3 pi over 2. And then my 11 pi over 6, which is still smaller than 2 pi. So it is still in my interval there. Okay, so then I'm going to plug those into my function. Now to save some time, you can use a calculator to do that. So plug those values in here and get your answers. I ended up, I'm just going to tell you what I got really quickly just to save some time on this video because we're over 20 minutes. All right, so this one ends up -1. This one ends up 3. This one ends up -3 over 2. Maybe you got -1.5 on your calculator depending on your mode. This one ends up -1. This one ends up -3 over 2. And this one ends up -1. So let's have a conversation about this. I have 3 of them that ended up -1. If -1 had been the lowest point in my group here, then all of those would be minimum values. In this case, it's not. My highest value is this one, so this is my maximum. My lowest value does actually have a repeat. It's -3 over 2. Those are my minimums because -3 over 2 is smaller than -1. So I have a maximum at pi over 2, 3, and I have minimums at 2 different points. One is 7 pi over 6, -3 over 2. My other one, so I'll say and, 11 pi over 6, -3 over 2. So those are my answers in this one. Just to go back for a second, I put these in order. I don't want you to waste a lot of time doing that. That was honestly me just being a little OCD. You can put these in any point, in any order that you want, as long as they are between your endpoints. So as long as you know they actually are in this interval, you can check them in any order you want. So if you wanted to just go through and say pi over 2, check it, 3 pi over 2, check it, and so on, that is fine. Okay, so that should give you everything you need to know about critical numbers. Don't forget to check when it is undefined. That's the biggest mistake I see people make is they forget to check that situation. They only check 0. So make sure you know when it's undefined, that is a critical number, and when it is equal to 0, that is also a critical number.